Alright, hello friends and aspiring shipbuilders. I've been seeing a lot of pictures online recently of different ship designs that people have had, and I've been noticing some trends about how people are designing their ships, and I just wanted to do a quick little tutorial video on a few points to be aware of, specifically around adjusters and cross sections. So I've done a lot of experimenting with different ship designs, ship types, how to do different builds. And I just wanted to relay a few things that I've found and how the physics works in this game. Because there's just a few things that I'm seeing a lot of people do that um, it's not going to be a super functional design. So I'm going to start with adjusters. So here I've got just a basic little test skid that I threw together, where you can see I've got two adjusters just above my head, two in front of me, and two at the back. So I just left them floating in space. So basically the ones at the back are my yaw adjusters. So you can see they light up a little bit as I flip back and forth. The ones on the top are my roll adjusters. So you can see they light up as I'm rolling. And the ones on the front are my pitch adjusters. So this is just a very basic setup. Looks like crap, obviously, where I just decided to throw them in there just so you could see how they function. So in this case, I am explicitly using adjusters for each of the yaw, pitch, and roll. Often in my designs, I'll have them work for both. So I'll do, like on the front corners, to do both roll and pitch. But that's more complicated. For this video, I just wanted to get into basically how adjusters work with your center of gravity. So right now you can see, I'm going to focus on the roll because it's really easy to demonstrate. So the ones at the top, you can see they're fairly far above my head. So when I tilt, there's a lever action going on. So basically they're farther away from the center of gravity. So as they push, it actually gives a lot of torque force because they're really far away. If they were closer to the center of gravity, then that push would apply less force in the angular momentum. So, and basically the big thing that I wanted to point out is also actually that they are perpendicular to the center of gravity. Well, to the line to the center of gravity. Basically what I've been finding is that a lot of ship designers are putting in adjusters where they're actually pointing towards the center of gravity, which is really not going to do you any good at all. So these adjusters right here, when you go into build mode, the center of gravity gives you this little cross here, so you can see I placed it sort of in the middle of my fuel tank. Or rather, I built the ship around it such that the center of gravity landed near the middle of my fuel tank. Now basically these guys here, they're pretty far away from it. So roll is going to be going across the center axis through the middle of the ship. So it's going to be tilting around that axis. So those guys, because they're far up above it, they've got a good torque on it. Now, if I were to lower them closer to it, worse torque. Now, even worse yet, if I were to angle them towards it, this is what I've been seeing. So here, I had them arranged like that recently. So if you put them here, even if you had them really far away, so let me go back in here and let's just bump this guy out. So he's real far away, he's way up above, but that line, he's pointed almost directly towards that center axis that it's supposed to be rotating around, right? So that same mechanical advantage that I was talking about earlier, where if it's pushing away, then it tilts. If it's actually pointed directly towards it, it doesn't do anything. So it'll push towards the center of the ship, which isn't, it's not going to spin you. So here, if I get into the ship again and take off and get out of the gravity well of this station that I'm on, now when I try and roll, you'll see it's nothing. I actually landed up so well that it's literally not rotating me at all. I can't actually roll my ship anymore because those adjusters, they're pointed so close towards the center of gravity of the ship that they're not actually applying any torque. They're just trying to push the ship, basically, which adjusters can't do. That's another thing about this game. Adjusters only apply angular momentum. They don't apply any actual directional momentum. So you can't use adjusters to push your ship, doesn't work. I think they did that just as a balance point because adjusters are free. They don't consume any fuel, so they didn't want to have a ship that can be powered by adjusters when that means that you basically have a ship that flies for free. Someone, me, would have just stacked a ship with like 500 large adjusters and just flown it just with adjusters. Because, I mean, why not if it's free, right? That's basically what I wanted to get into about the adjusters and rotation matrix. I didn't actually talk about the matrix at all, but that's because honestly, I find the matrix actually really difficult to work with. Oop, went back too far. There is technically here, the inertia matrix, which shows how your stuff works. But honestly, I really find it confusing. I'm not actually sure exactly how it works, because like here, my yaw, pitch, and roll, it actually looks like it says they're fine. But we just proved this ship has no roll. So I don't actually know how this works. I don't know. So yeah, I just ignore it. I just go off of an intuitive understanding of how it works. So here, that was the roll thing. If you look at some of my other ships, I tend to make them a little bit on the wider side and then put the adjusters on the front corners. So here, these guys will work both for pitch by firing both sets at the same time, it will pitch forward, or if it fires only one set at a time, it will roll sideways. So I can have those ones there, and then similar ones at the back, they're buried under the Voxworks, so you can't see them. And then basically, yeah, then it has both pitch and roll. So I apparently need to fix that guy. Now, cross-section. So I've done some experimentation with different burn speeds to try and figure out like how fast you can fly before your ship lights on fire and starts taking damage. And in the process of doing that, I found that the cross-section is huge for the amount of speed that you can have. I was trying to build different cross-sections to see like how fast, like when they would burn. But in doing so, I found that as you increase the cross-section, like it creates a massive amount of drag on your ship, which actually makes it really difficult to accelerate. So here, just as a quick demonstration, I wanted to show wings. So these wings are small wings, and right now they are at z equals 0. So if you look on the side there, it tells you exactly where it is. Now, if I look at my frontal cross-section, which is under, nope, not there, atmospheric flight engineer. So I'm just going to tuck this over to the side so we can still see it. So the frontal cross-section is 2.56. So I'm not exactly sure how they did the code, but it seems to me that basically what they're doing is they're sort of representing the shape in like, they're sort of like compressing its dimensionality. That's not really a good explanation. Basically, it's long and flat right now, and so it has very little cross-section. But something about the way they treat it being on different angles and things, it's no longer flat, and so its surface area seems to increase drastically. So the way I think of it is like if you draw a pixel line in paint, if you draw it really like with thick pixels, if you go like a complete straight line, basically it's treating that as being almost empty. But once you start tilting it off to the side, then each of those sections basically starts to like grow and expand, and it actually creates a much larger cross-section for some reason. Also, its specific location seems to matter. So here this is at, hang on. Sorry, this is at z equals 0.5. And my cross-section right now is at 2.56. Now if I take this and I bump it down, up to z equals 0, and watch that 2.56, it takes a second to update also. Now it's 1.88. I didn't change anything. It's still the same wing, but it's in a slightly different location, and so my cross-section is different. So here, again, negative 0.5, bump that one up, and give it a second, because it takes time. Yeah, never mind, 1.19. So just by moving it to be on 0 instead of 0.5, my cross-section's improved dramatically. And it's something about the rounded numbers. So it's If I bump it up to 2, it will still be fine. But if I drop it down to 1.5, boom, back up to 1.88. So if you want to keep your cross-section low, which you do, because drag really slows your ship down, you want to keep them right on the 0. Now, more importantly than that, angled ones. So if I take this guy and I put him here, actually, hang on, I think I got an angled voxel over here somewhere. But right here. Okay, here. So I was at 1.19 before I moved this guy when he was nice and flat. Now I'm at 5.19. So by taking that same wing, angling it up at a 45-degree angle, I went from 1.19 to 5.19. So if I remove this entirely, it's 1.19. So by having it flat on an even number, it's like it doesn't even exist. It literally, the cross-section doesn't even know it's there. Put it on an odd number, goes up to 1.88, so it gains about 0.8 square meters cross-section. But put it at an angle, suddenly it's 4. So yeah, much as you can make cool looking ships like this, not that this one looks cool, this looks like crap, but that's fine. Much as you can make cool looking ships with angled wings, you got to be aware of the performance impact of them, that it actually makes a huge difference on how fast your ship is going to be able to fly. So if you take the same ship and just take it and stick your wings at an angle, if you were keeping your cross-section low before, you will see a dramatic difference in how fast you can actually fly in atmosphere. Yeah, that's basically it. Cross-section doesn't really apply in space because no atmosphere. Other thing about cross-section I like to say is keep everything in line. As much as you can, like, what you absolutely do not want to have is you don't want to have, like, here's an engine, and then we're going to put our brakes, I don't know, over here, nice and flat, and then we're going to put this guy down here, and then we're going to put the fuel tank over here. So now they're all taking up their own cross-section, and that 1.18 has gone up to 3.56. So basically, like, really you want to keep as much as you can in line with the ship in the direction of travel. That's how you're going to keep a nice tight cross-section. And like that's why a lot of the ships do that. Like you look at the light skippers here, Obi-Wan Kenobi's, Warp Shuttle, pretty much, I mean, it could be narrower because it's got the warp drive at an angle, or rather sideways, but you pretty much have your engines, and then almost everything fits within the range of those engines, right? So if you look just at the engines, and then look forward, almost all of the ship fits in that area. And that's very common, and for good reason. This here is the Celerity, that's one that Jack Crash made. Very similar design. He kept the warp engine going straight in order to reduce that cross-section a little bit further. Same kinds of engines, slightly lighter voxel work, it's using lithium. Keep the weight down. But yeah, basically, you want to tuck as much as you can all in a line, or else you're adding cross-section, and that cross-section, it's killer. It's killer. You gotta watch for it. Alright, yep, so this was my quick little video about adjusters and cross-section, and hopefully it helps somebody. Alright, thanks.